In this lesson, we are going to learn how to graph exponential functions, and then do the domain and range, and also these graphs will have asymptotes. So we're going to look for those also. Our first problem you can see is we have y equals 3 to the x. And so this is an example of exponential growth because we have a base that's higher than 1. So to graph this, all you have to do is put it on your calculator. You could, of course, make a table, but we're going to use our calculator. So I'm going to go to my y equals, and I'll put 3 raised to the x. And then when I hit graph, my zoom is off. So I'm going to hit zoom 6. There we go. And there's my graph. You can see it's exponential growth. And so to plot these points, you're going to try and graph as many ordered pairs as you can by looking at the table. So I'm going to start at my table, and I'll go down here. Mine's at -5 years again. Could be something different. So it looks like I have 0, 1, 1, 3, and 2, 9. So I'm going to plot those first. 0, 1, 1, 3, 2, 9. Then if you keep looking at your table, I had 327, which is right here. And that kind of fills up my graph. The other ones by decimals, I'm just going to estimate. You can see that I have -2 and 0.1, -1 and 0.3, so 1/3. If I go up, you'll notice that as I go higher, I'm in scientific notation there, aren't I? That -11 would be 0.000056. So I'm getting really, really close to 0, but notice I'm never hitting 0. I'm just getting smaller numbers. If I were to go to a different part of my table and pick a really big negative number, like let's say -500. And then we'll go to our table and look at that. Oh, not my X-Men, sorry. That's not what I wanted to do. We'll go back to normal. I want to do table set. I accidentally hit window. There we go. I'm going to start at -500. And then when I go to my table, you'll notice it says 0, but that's because I picked such a big number that my calculator can't round. So at some point it's going to say 0. It'll never say a negative number though. So what's happening on this graph, if you look at the graph again, it looks like I have a horizontal asymptote at 0, doesn't it? If you take a look and I draw in this line, my graph is approaching 0. And we talked about this the first day we talked about graphs in the first part of this chapter. But we haven't actually graphed any. So we do have a horizontal asymptote there. So if I go to my notes, I'm going to draw in that dashed line, just like we did when we studied those in chapter 9. So my asymptote, you'll notice it says down here, my asymptote, I'm going to write y equals 0. I do have one, and it's at y equals 0. And then I can go ahead and plot, I think it was -1 and 1/3. You know, you'll see that you're getting closer to 0. So I'm just going to draw this graph approaching 0, and then connect the dots on the rest of it. And there's my exponential function. So as I do my domain and range, remember your domain is your x values going across. I'll just draw on a line here. And as I move this line, I'm touching at -infinity, aren't I? Because that line goes on forever. And where do I stop touching my x values? Hopefully you see that that's never. So I'm going to put in for my set notation, I would say values of x such that x belongs to all reals. An interval would be -infinity to +infinity. And then my range, go ahead and flip this to make it horizontal. And maybe we should make it straight, huh? There we go. So as I bring this up, notice I'm not touching at 0. 0 is my horizontal asymptote, right? So I'm not going to touch at 0, but everything after 0 has a y value. So starting at 0, I touch forever. So I would say for my set notation, values of y such that y is greater than 0. And then for my range, on my interval notation, I'm going to start at 0 with a parenthesis, so you know that I'm not touching 0. And then I go to +infinity. So that's all you have to do with the graphing of those, and you'll do that a little bit of that in your homework. Or sometimes you might just be given the graph and you have to be able to identify the domain and range. The last one we're going to do with graphing is an example of exponential decay, because my base is 0.25, so it's between 0 and 1. I'm going to put this on my calculator to see what it looks like. So there I'm going to go 0.25 raised, oops, I forgot my decimal. 0.25 raised to the x. And then go ahead and take a look at that graph. Hopefully you recognize that's exponential decay. And so I'm going to plot some points here. If you remember my table, I had it set at negative 500, so I have to fix that, and I'll start at 0. How about? And now looking at 0, I have 0, 1. Let's go back and see what we have. Lots of them back there, right? So let's plot 0, 1, negative 1, 4, negative 2, 16. So 0, 1, negative 1, 4, negative 2, 16. And then looking back at my table, I have 0, 1, I did 1.25 and 2.065. So hopefully when you look at this graph, you can see that it looks like, again, we have a horizontal asymptote at 0. It's just that now we're decaying. And we should know that from our first day of the chapter, but I just want to remind us of that. So when I go in here, I'm going to draw in that dashed line for my horizontal asymptote. I'm going to put it down in my answer too. I have a horizontal asymptote at y equals 0. And then I'm going to connect my dots. I think this one was 0.25. So we're going to just gradually approach 0 but never touch it. Let me go up here. So there's my graph. If I'm going to do domain and range again, hopefully you can see that your domain is still all real numbers. So values of x such that x belongs to all reals. And then for interval we'd say negative infinity to positive infinity. My range, again, I start touching right above the 0 and I touch forever. Even though my graph is going the other direction, instead of growth it's decay, you can notice that it's still going, starting at 0 and going on forever. So my range will still be values of y such that y is greater than 0. And then my interval notation would be 0 to positive infinity. So we got the same thing for both graphs, whether it was growth or decay. It's just that the graph looked different. If you have any questions on that, make sure you let me know.